Well, hello everyone. I am recording. So this is going to be our very first video of our lovely series of review of Algebra 1, Algebra 2 concepts.
There we are.
So right now we're cooking with gasoline. Okay, so this is what we're going to be doing. We are going to do operations of integers. So we're looking at the Common Core standards of A, meaning algebra, SSE 0.1, and A, meaning algebra, APR 0.1. So we're going to look at, or we're going to try to, our learning targets. I can distinguish between rational, irrational, and complex numbers using that Venn diagram, and I can add and subtract whole integers. So we're actually going to be looking at the different types of numbers, as well as doing some basic adding, subtracting of integers. So that's what's going to be going on in this video. So for our agenda, we're going to investigate the types. So look at the real from complex, and we're going to add, subtract integers. We're going to do a little practice, and then for closer, your guys are going to do a mini quiz. So let's take a look. All right, so we have the types of numbers. So numbers in general is just a way for us to count, okay? And if you notice, usually we count with our fingers. So we go like from 1, 2, 3, 4, 5 to 5, 4, 3, 2, 1. And those numbers are called our counting numbers. So you see right here, counting. So our counting number is basically going from like 1, 2, 3, all the way up to positive infinity, okay? So we have those natural numbers. Sometimes they call the counting numbers our natural numbers, so we got that. Now we have our whole numbers. Our whole numbers is also have counting numbers a part of it. But with the whole numbers, it starts from 0, and it goes from 1, 2, 3, 4, all the way up to positive infinity, okay? So whole numbers, whole, has a 0, goes all the way up to positive infinity, where your counting numbers, with your fingers, you start with 1 and you keep going. Now, integers, this is when your life just kind of got all kinds of crazy when we got into algebra. So the integers, it talks about your 0, which is part of your whole number, 0, 1, 2, 3, 4, 5, right? All the way to positive infinity. But it's also looking at the opposites. So the opposites, you got your -1, your -2, your -3, and all the way to negative infinity. Okay, so your integers deal with the positives and the negatives of the numbers, and it also includes your whole number of 0. Okay, now your rational numbers, this is what's happening really in between numbers. So this is stuff that's happening between 0 and 1, between 1 and 2, between 5 and 7, between, all those things is in between. So we're looking at our 1/3. We're looking at our 0.76. We're looking at our 10 over like 3, okay? So we're looking at mostly those numbers that's in between the 0 and 1, that's in between those whole numbers, that's in between those integers, that's in between those counting numbers. Now, when we're looking at all of those, there's also another realm. So we have our rational numbers, which covers our counting numbers, our whole numbers, our integers, both positive and negative, and also the stuff that's in between. The irrational numbers, it's basically dealing with your pi, okay? Your square root of 2, all right? So those prime square roots, remember the square root of 7, okay? So these are numbers, and also there is proof that e, remember we just left off with the exponential, so that's going to be considered an irrational number, a number that's not necessarily giving you whole numbers, it's something that keeps going on and on and on and on and on. So like pi, it has their start and it keeps going on and on and on. And I mentioned that e could be irrational numbers, but there has been proof that some people say it's not an irrational number because there is a pattern within that. And if we looked at it, it was like 2.71825182518251825. Because those 4 digits keep repeating, that's why some people say it's not irrational numbers. But some people are proving, well, it is an irrational number because it doesn't end. So there's a controversy. They're going to have to deal with it, okay? But when it comes to the square root of 2, that doesn't give us like a defiant number. It just keeps going on and on and on and on. So you have your rational numbers, you have your irrational numbers, and both of those concepts are called real numbers, okay? So those real numbers, if they ever ask you, is this a real number? Is pi a real number? Yes, it is. It's part of the irrational family. Is 2/3 a real number? Yes, it is. It's one of those rational real numbers. Is square root of -1, is that a real number? Nope. You see the circle over here? This is going to represent our complex numbers. So now those complex numbers, that is that square root of -1, which represents, don't let me down, don't let me down, what represents the square root of -1? Thank you, some of you guys, I. Okay, so if you ever notice that when we have those expressions, when we have those equations, we never use the letter I and we never use the letter E as variables because they actually represent numbers in mathematics, okay? It's one of those translations that kind of helps us to even things out. So when we had our square root, as soon as I can get my thing, as soon as we have our square root of -4, remember, we always had to factor out that square root of -1, which the square root of -1 is just equivalent or compatible to I, and the square root of 4 will give me 2, and that's why that solution will give me 2I. So complex number is in the world all in itself, okay? So rational, irrational are your real numbers. They're together. They're together. They're tight. Complex numbers, they're the little side piece on top, okay? So that's basically what's going on with the different types of numbers. So you have counting, whole, integers, both sides, and rational, what's in between, okay? So that's all in one group. Then you have your irrational, that's your pi, your E, yeah, okay, your square root of 2 and square root of 7. And then you have your complex numbers, which is definitely your I series. So your A plus BI, your A minus BI, your I squared, all that fun stuff, okay? So that's the different types of numbers. Moving on. So I'm going to give you a listing. Is it rational or irrational? So can I say -1/4? Is that rational or irrational or complex? It's going to be rational, okay? Because it's a fraction and it's also an integer, okay? Because of the negative. So if I give you pi, that's going to be irrational. And then complex, so if I said 3 plus 4i, that will be an example of a complex. And remember, complex numbers comes in pairs, so it'll be 3 minus 4i, or sometimes it'll be written as 3 plus minus 4i, okay? These two things mean the same thing. So rational numbers, we got it. Irrational numbers, a little irritating because they definitely keep going on and on and on. And complex numbers, that's going to be your I series. So if we look at the continuation of this, how we're going to add, subtract, multiply, or divide these integers. So the conclusion of this video is going to be just addition and subtraction, whereas the next video is going to be multiplication and division, okay? So helpful hints for adding integers. So always follow the signs of the answer first. So any number without a sign, you assume it's positive. So if I say 6 minus 7, we're assuming that the 6 is a positive 6, okay? And you always follow the sign of your answer first. The sum of two negatives is a negative. So if I say -4 plus -4, my answer is also going to be negative. And sum means addition. So that means I can just add -4 and -4 and get my -8. And then when you're adding a negative and a positive, you're going to subtract. So if I go back to my original 6 minus 7, and if I just write it as 6 plus -7, okay, I'm going to take the sign of the largest number, and obviously 7 is larger than 6. So that means I'm going to have a negative, but then I'm going to subtract. So it's almost like if I want to, I can flip it around. So instead of saying 6 plus -7, I could say -7 plus 6, or, so I can see that, oh, 7 is larger than 6. I'm going to take the sign, which gives me a -1. Okay? So when the signs are opposite, you're subtracting. When the signs are the same, you're adding. And you're just going to keep the sign of the original. So when you're adding more than two integers, you want to group the negatives and the positives separately. You can do that and then add, or you can just try to keep track of, okay, let me do my operation for the first couple, take that answer for the next one, take the answer to the next one. So you can do it one of two ways. So let's look at a couple examples. So we have -7 plus -5. So we got a negative plus a negative. That means my answer has to be negative. And since both of them are the exact same sign, we're going to add. So 7 plus 5 gives me 12. So actually it's going to be a -12. So if we're getting a little complex with just adding and subtracting without a calculator, which I know some of you guys is a little challenging, but we're going to need to take this practice. Hence, that's why I'm doing this part right now. Okay, so I'm looking at -7 plus 9. I can also rewrite this as 9 minus 7. As long as the negative symbol is connected to that 7, and long as the positive symbol is connected to that 9, you can rearrange it to see it a lot better, a lot clearer. So 9 minus 7 equals 2. So guess what? -7 plus 9, that also equals 2. So they basically are exactly the same, okay? So now for this one, it kind of goes back to what we said before. Let's see if I can go back. Yes. When adding more than two integers, group the negatives and positives separately, then add. So if I'm looking at this, I could put all my negatives together. So that'll be -6 plus -5, and then I have my plus 4. So negative plus a negative will give me a negative, and then I'm going to add 6 and 5, which gives me 11. Now this plus 4, it's going to come right on down. So now I got -11 plus 4. Both signs are opposite. Which one's larger, 11 or 4? 11. So I'm going to take the sign of the 11, which is negative, and then I'm going to subtract the 2. So 11 minus 4 gives me 7. So my answer for this is going to be -7. If you want to just go down the line from left to right, because that's how we naturally read, you can do that. So -6 plus 4 gives me -2, and -2 plus -5 gives me -7. So you can do one either way. So either you want to group your negatives together and positives together and then take it by separately and then combine at the end, or you can just go just exactly from left to right. So let's try the next one. So 15 plus 8, then we got plus 12 plus -6. I think I said plus 8. It's supposed to be plus -8. So if you want, you can group your negatives. So that's -8 plus -6. So I can group those two. And then I'm going to add and then group the 15 plus the 12. You can do it that way. So -8 plus -6, my answer is going to be negative. And I add them together to give me 14. bring down my plus sign. Now I have 15 plus 12, which gives me 27. Erasing things. So now I have negative 14 plus 27. So they're both opposite signs. One's negative, one's positive. Which one's larger? The 27. And the 27 is positive. So we already got a positive number. So we don't have to put the plus sign because we always know it's always going to be positive. But we are going to subtract, which gives me 13. Okay? And if you're one of the ones that just went straight from left to right, did you get the same answer? You should. Okay? So, going with the next part. So now with the subtracting integers is very much the same as adding. Okay? So to subtract the integer means that it adds its opposite. And we did a couple examples actually on the other part. So don't let double negatives confuse you, please. Because when you have, let's say, 4 minus a negative 3, I kind of like think of it this way, like I'm about to walk out the door. Oh, I forgot something. Now I got to go back, grab what I need to go, then I come back. So a double negative is like you going forward, going back, and going forward again, okay? Like a little dance move, you know, just a little swag. Okay, I'm stopping. So when you minus a negative, it actually does the opposite. It turns positive, okay? And that's why when we do the multiplication, when you have a negative times a negative, it turns positive because double negatives make something positive, okay? Which in this case will give you 7. So think of subtraction as addition in disguise, hence the face. So now, oops, a couple of examples. So you got your 15 minus 27. So you can say a negative 27 plus 15. You can see it that way because now you can see that the 27 is larger. My sign is going to be negative, and that means I'm going to subtract, which gives me 12. Then here, negative 3 minus a negative 8. When you minus a negative, that means this first one stays, but these change. So now I got 8 minus 3, which gives me 5. And all I did was, this is going to be a positive 8. That's where that came from. This is a negative 3. That's where that came from. 8 minus 3 gives me 5. Okay? When you minus a negative, that means, well, actually a negative and a negative, my answer is going to be negative. So now I'm just going to add, which gives me a 33. I'm like guessing right now because my brain is like dead. So we got 9, that's 15, that's 16, 36. Definitely not that answer. So, so here we have our 4 minus 16. So this always gets people. They're like, oh, it's 20. No, it's not 20. And the reason why it's not 20, because this 4 is positive. If this 4 was negative, I would definitely say yes, it's a negative 20. But since it's positive, it's the same as saying negative 16 plus 4, which does give me a negative 12. Then I bring down my negative 19 from up here, okay? So now I got a negative and a negative. That means my answer is going to be negative. And then I bring it over, which gives me a 31. All right? So for the most part, we got like 20 minutes. We did everything. So we're looking at our learning target. Did we distinguish between rational, irrational, and complex? Yes, we did, using that Venn diagram. Did we do adding, subtracting whole integers? Yes, we did. Okay, we kind of looked at the real and the complex through the Venn diagram. So we did that, and we did our notes and example. So the only thing you have to do is go ahead and do your mini quiz, which I'm actually going to add on top of this. And once you do that, I'm going to grade it. Actually, it should grade automatically, and everything's going to be good. All right, so not bad. Part 1, I think we can do this. All right, take care now.